The objective of this lesson is to learn about the scope of variables in Python. To refresh your memory, you learned in previous lesson that in Python, each module, function, or class has its own namespace. When a function is called and starts execution, a namespace is created for it. And when a function finishes execution, its namespace is deleted. Since multiple namespaces exist at different times, then every time that a variable is used, Python searches the appropriate namespaces to find the value of that variable. This means that all variables are not accessible from all parts of a program. The scope of a variable is that part of the program where that variable exists and it is accessible. When Python searches to find the value for a variable, it has a search order. And that search order is that it first searches the local, then enclosed, then global, then built-in environments. You can memorize this by memorizing leg B, which is local, enclosed, global, and built-in. So what do they mean? Local is the namespace inside a function or a method. So as long as you are inside a function, any variable which is defined inside that function is local to that function. Enclosed is the namespace of the enclosing function. Global is the namespace of the uppermost level of the executing code, or actually the namespace for the main program. And built-in are special reserved names for Python. So basically, when you try to use a variable in Python, Python first searches the local namespace. If it is found, then it will use it. If that variable is not found in the local namespace, then it looks into the enclosed namespace, which means the function which wraps your current function. If it is found, then Python will use it. Otherwise, it goes and searches the global namespace. Again, if it is found, then it will use it. Otherwise, it goes and looks into the built-in names. If it is found, then Python uses it, and if it is not found, then you get an error for undefined variable. Let me go through an example. I have a function called fun1. Inside the function, I define a variable x with a value of 7 assigned to it. This is a local variable. That means the value of that variable is locally defined in the namespace of function1. When I print the value of this variable, then Python gets the value of the local variable. I also have in the main program another variable with the same name called x, and the value of it is 15. Let me use Python environment to show you this example and some variations on this example. Here is the exact same code that I showed you in a slide. If I run this code, notice that the output of the first printf statement is that the x inside the function is 7, and when I print in the main program, the value of x is 15 because the x inside the function comes from a different namespace table than the x which is in the main program. I am going to delete this particular statement. So that means inside the function, I do not define x and I do not assign any new value to it. What do you think will happen when I run this program? The answer is the printf statement inside the function prints the value of x being 15, and the print statement outside the function also prints the value of the x to be 15. The reason for that is when you are inside the function and you try to print the value of x, Python uses the leg B rule. Remember, the leg B means Python first looks into the namespace of local variables. The namespace of this function does not have any variable x defined when it gets to this printf statement. Since Python does not find the value of the variable x in the local namespace, then it goes to the next level, which is the enclosed namespace. The enclosed namespace does not include a variable called x either. Then Python goes to the global namespace and looks for the name x. And in that place, it finds out that the value of x is 15 in that namespace. And that is the value it's going to use and print. In the second printf statement, when Python encounters the variable x, since this line is in the main program, Python only looks into the global namespace, and of course the value of x in that case would also be 15. Now let me show you another example. In this example, I have defined function 1, and inside the function 1, I defined another function called function 2. Notice that function 2 is enclosed inside function 1. And then the main program starts with this statement when it says x is equal to 5, and then it prints the x in the main program. Then it calls function 1. When the program jumps to the function 1, the first thing it does, it defines function 2, then gets to the statement when it says x is equal to 7. It prints the value of x, then it calls function 2. When it goes inside the function 2, it tries to print the value of x. What happens here is that inside the function 2, the variable x is not defined. So Python uses the leg B rule. Leg B means first look at the local namespace. What is the local namespace? The namespace for function 2. In that local namespace, there is no variable x. So what it does, it says go up and look into the enclosed namespace. What is the enclosed namespace? Is the namespace for function 1. In that case, it finds the variable x and the value of it is 7. And that's why inside function 2, the variable x is also printed as 7. Let's look at this example in the Python environment. Here's the exact same code which was in a slide, and when I run it, of course you see that this line comes out of the main program. This line comes from the printf statement in the function 1, and this line comes from printf statement in function 2. Now what happens if inside the function 2 I also define the variable which is called x? So let's say inside the function 2 I put a new value for variable x. It is obvious that this time when I run it, the first line comes from the main program. The second line here comes from the function 1, and this x comes from the function 2. And as you can see, each of these functions and the main program keep their own namespace table and their own variable x. Now let me go back to the original example and run it with the same exact output. Now what if I want to use the global value of the variable x in function 2? All I have to do in this case, I have to use the keyword global and define x here. This time if I run my program, when Python encounters the variable x in this printf statement, it knows that the variable x is the same variable which is in the global namespace of the main program. And for that reason, it uses the same value, which is 5. Remember again that inside function 1, the variable x is still local to function 1, and the global variable is not used. So if I want to use global variables inside a function, I have to explicitly define them by using the global keyword. My advice to you is try not to use global variables as long as you can. Global variables are very dangerous because they change the value of a variable outside of the scope of a program, and they have side effects which make your program much more difficult to debug in case something goes wrong. Let me give you an example of this. If I define x as a global variable inside my function 1 and then try to print it after I called my function 1. Let me put this statement here so you know that it has been printed the second time. Now if I run my program, you see that the first time in the main program the value of x is 5. Then it goes and runs inside function 1 and 2, and when it comes back, if I print it again, which is this statement here, you see the value of it is changed. Now a person who looks at this program and looks at the codes inside the main program will get confused because it thinks that, okay, the x was set to 5, then you printed the x and the value of it was printed as 5, fine. Then you called function 1, and when it came back from function 1, the value of x is changed, and that person does not know what happened because that person may not be able to look inside function 1. It could be inside one of the modules or packages that person is using and is not familiar with it. using a global variable inside a function is dangerous, and it is more dangerous to even change the value of a global variable inside a function. What did you learn in this lesson? You learned about the scope of variables in Python.